We're going to finish up the notes for chapter 6 today, which means your next unit test is just around the corner. What I wanted to show you again is to make sure, I hope you can see this, is you ran this chart off. This is the periodic table of ions. And what we're going to talk about is these guys in the middle. Okay? Those are called polyatomic ions. And what a polyatomic ion is, it's a molecule with a charge. Okay? So you've got like phosphorus and oxygen together, but in order to be stable, they had to borrow a few electrons, so they have a negative charge. Okay, and there's a whole bunch of them, and they're in the middle. The nice thing about polyatomic ions is you just write their name as is. You never change it. You don't change the ending to IDE or AT. Leave the name as is. Okay, so never mess with the name of a polyatomic ion. But really what it is, it's a molecule with a charge. So it's like a molecule and an ion combined. Here's an example of cyanide. Nasty stuff, you guys. Don't ever mess with it. But it's a carbon and a nitrogen together. And so they're stuck together, so they're molecule, but overall they have a -1 charge. And this is where you'll see the charge. Like sometimes you'll see a number down here. That is not the charge. The charge is up here, okay? So when you combine it, you just, put it together like you normally would. Name the first one the metal. And again, polyatomic ions are going to combine with metals because they're ions. They're charged particles. Okay, so you leave the cation name as, whatever the metal is, and then you put the anion name. If you're writing the formulas, remember, you got to write the symbols, you got to write the charges, and then you got to balance out the charges, okay? The polyatomic ions now you might not know very well, but after a while you'll know SO4 is sulfate and PO4 is phosphate. And there's some we use a lot, some not so much, but again, you'll learn them after a while, okay? And ways I know there's a polyatomic ion, because especially right now you don't really know them, is if you have more than 2 capital letters. Okay, there's got to be a polyatomic ion. If it just says capital C, little a, capital O, that's calcium oxide. There's only 2 capital letters, so that doesn't have a polyatomic ion. But if you see Ca, capital A, little a, capital S, capital O, and a 4, now I know there's a polyatomic ion because there's 3 capital letters. So look for more than 2 capital letters, and you know you got a polyatomic ion. Okay, so here, when you're naming a compound with a polyatomic ion, you name the cation, the metal, with a positive charge, and then you name the anion. Here's some popular ones. On your chart, acetate, I'll have to read it, is listed as CH3COO. It's the very first one listed. Okay, you'll see it listed that way, or you'll also see it, and it's more common this way, C2H3O2. So you might want to change that. It's up to you. But it has a -1 charge. So if you see this in there, it's just acetate. Okay, NH4, this is one people get all confused about. It'll have ammonium, and everybody are looking on the periodic table. What element's ammonium? What element? It's not. It's a polyatomic ion. It's NH4, and it has a +1 charge. And honestly, this is the only positive one you'll use. This is the only cation. All the rest of them are anions. So you can see we have hydrogen carbonate, hydrogen sulfate, bromate. Carbonate is a very common one. Chromate is a common one. Nitrate, NO3, is very common. Sulfate, SO4, phosphate is very common. So these are, but they're all listed in that chart in the middle. And then make sure that you remember, dichromate is Cr2O7. That's its formula. This is the charge. Some people think this is the charge, and that's not the case. Make sure you look up here for the charge, okay? And then you just put them together like you did before. So if I have calcium carbonate, I'd put calcium, Ca, carbonate, CO3, and then I'd make sure the charge is balanced. Okay, so if I'm going to name this one, Na is just sodium. Okay, NO3, I look it up on my chart, and it's nitrate. And there's nitrite and there's nitrate. Nitrite is NO2, so you got to be careful. You got to look them up. But don't, please, please, please don't write sodium nitrogen trioxide. Don't do that, okay? Don't make it harder than it is. If it's a polyatomic ion, just write its name as it is. So just be sodium nitrate, okay? This one, K is potassium. Cn is cyanide. And again, don't put Roman numerals. Roman numerals are only for the ones that have more than 1 oxidation number, okay? So just be potassium cyanide, okay? So, and yeah, this one, if you guys write potassium monocarbon monoxide, I really might have to shoot you in the face or send you a blah or something. I don't know. Just don't do that, okay? Don't make it harder than it is, you guys. Okay, here's lithium. Okay, And then you go, oh, what's ClO2? And then you look up on your chart and you go, oh, ClO2, where? There you are, chlorite. Okay, and again, you got to be careful with the chlorines because there's chlorite, perchlorate, hypochlorate, you know, there's a whole bunch of them. Make sure you look for ClO2 and it's chlorite. Okay, and again, that's all you have to do to name them. Name the first one, name as is. The second one, change, you know, the polyatomic ion, leave its name alone. Okay, name the following. NH4, like I said before, that's ammonium. Okay, that's a polyatomic ion with a +1 charge, and iodine's -1. Okay, now when you're writing the formulas, you do just the opposite. Okay, write the symbols. Okay, lithium is Li, chlorite is ClO2, and you'll see its charge is -1. So you have +1, -1. Hey, they equal each other. We're all good. Okay, and you know what? I should have had some with the charges, but I didn't. Let me see if I didn't. Okay, one thing that I didn't have listed on here, and I should, is if you have a polyatomic ion and you need more than one. Okay, let's say we're using bromate, and bromate has a -1 charge. Let's say we're combining it with calcium. Okay, so calcium would be Ca, and it's +2. Bromate is BrO3, and it's -1. So the charges don't equal each other. So I need 2 bromate groups. So what I need to do is I need to put this in parentheses and put a 2 on the outside. So whenever you need to take a polyatomic ion and you need more than one of them, okay, let's say I had copper 2 acetate. Copper is 2 and acetate is 1. So it'd be Cu, and then I'd put acetate in parentheses and a 2 on the outside. The one that people forget the most, which is funny, is hydroxide. Hydroxide is OH. Okay? And a lot of people like calcium hydroxide. They'd write Ca is +2, hydroxide is OH, and it's -1. So they'll write CaOH, and then they'll put a 2 just by the hydrogen. Okay? You need to put OH in parentheses and a 2 outside. So whenever you have a polyatomic ion and you need more than one, because you do the same thing, these are ionic compounds, they have charges, you have to make sure they balance out. If you need more than one of these guys, you have to put in parentheses. Again, if I have NO3 and I put a 2 on the outside without the parentheses, it looks like NO32. I don't need 32 oxygen. I need 2 of this group. So make sure when you're writing the formula with polyatomic ions that you make sure that if you need more than one of these guys, you put them in parentheses. Okay? And I'm sorry I don't have any examples there. I should have some. What I did after this, because we're done with this, the notes for chapter 6, I'll also have 2 PowerPoints. One reviews naming molecular compounds and one reviews naming ionic compounds. And you can go through those on your own. It's just examples. You know, it says, do this, do this, do this. Here's an example. Do this, do the example. So those are for your, you know, if you need them, if you want to take notes from them. If you got this, don't worry about it. But make sure you have this guy. Whoops, I had it upside down. Sorry. Have this guy, because this is a really excellent way of helping you with your compounds. Did they have that? Okay. Yeah. So make sure that you have that run off in front of you, because when you name compounds, that's like the best thing I've ever found. Okay. All right. So we're done with this part. We're going to take a quiz on them. And again, I'll have 2 extra PowerPoints for you to go through if you want to practice more with your naming skills. It's really important that you know how to name compounds, because we use this now for the rest of the semester. And I'm not going to review how to write formulas. This is something you need to know. So when we're balancing equations and I tell you to write out a formula and I just give you the names, you need to be able to do that. Okay? So make sure that if you don't understand this, that you get a hold of me and I'll give you some other stuff to help you. All right? So done with chapter 6.